Good morning, everyone. Today we will be doing the reproductive system. Now, like I said before, it's pretty short lesson. We should be done maybe in 2 hours. We'll see. I always say that and then end up going all the way to 11 o'clock, right? We never know. It is the second last lecture of the course, actually, and it will nicely tie into the last lecture, the endocrine system, because we're going to be learning quite a few hormones today, and then we'll fill in some hormone charts, and we'll see how it goes. Okay, so reproductive system. We will start with the female reproductive system, just because the mechanism in terms of hormonal regulation is more complicated, and it takes more time. And then we will finish up with the male reproductive system. So here is mid-sagittal section of female reproductive system, and we're just gonna go ahead and label that on our course pack. Sorry, study guide, I mean. So we can pull that out, and we're gonna skip the male one, and here is the female reproductive system. Okay, so I took out some stuff that we don't really have to know. We're just gonna label some of the key features of the diagram, on the diagram. Okay, so here we have the ovaries right there. There are, of course, two ovaries, one on each side, and that's where oogenesis occur, right? The production of an egg, right? Using meiosis that you've learned last semester. And we're going to look into that process in more detail afterwards. But there is your ovary. And there are these like hairy structures over here that will help guide the egg into the fallopian tube. Okay, and that is called the fimbriae. Okay, so guides, this is plural, so guide the egg into the fallopian tube. Okay, which is right here. Just right here. Okay. That is fallopian tube. Or oviduct, right? Both are okay. And there are two, of course, one on each side, connecting the ovary to the uterus. The fallopian tube is the site of fertilization. That's where the sperm meets the egg and fertilize it. If fertilization happens elsewhere, then there is a chance for ectopic pregnancy. Ectopic pregnancy occurs when the fertilized egg implants itself elsewhere in the reproductive system instead of the uterus, and that's very dangerous for the female, because it could irreversibly damage the reproductive system if not dealt with quickly. So there's a big structure here that I'm sure you know is the uterus. That's where the baby grows. Okay. So that's the E right here. E is like the whole thing is the uterus, where the baby grows. Okay. And then the main body of the uterus, it's called the fundus. Okay. Now, when we go further down, the neck, sort of like the opening to the uterus. Does anybody know what that's called?
Cervix?
That is the cervix, that's right. So the cervix is kind of like the opening into the uterus. And during pregnancy, there's a mucus plug that will seal the cervix. So nothing goes in, nothing comes out as the baby is growing, right? You don't want things to go in there and potentially harm the baby, right? Like bacteria and fungus and that kind of stuff, right? So everything is blocked out. And before birth, the mucus plug will come out, okay? And then the water will break, and then it's time to go to the hospital. Now, the lining of the of the uterus, it's right here, just the inner lining. Okay, so that is called the endometrium. Okay, endometrium, this is the inner lining, the lining, we can say lining of the uterus. Okay, and it's lined with blood vessels, which will support the growth of the baby when there is a pregnancy. Okay, when there's no pregnancy, then on a roughly monthly basis, it will grow in anticipation of pregnancy. It will get thicker and thicker and thicker. And then if there's no pregnancy, then all the new blood vessels that are formed will shed, right? And then that's the period, right? So that the thickness, okay, thickness is regulated by estrogen. And what's the other hormone?
Progesterone.
Progesterone, that's right. Thank you. These are steroid hormones, okay, and you'll see they're actually made in the ovary. Okay. Now the muscle of the uterus is very strong because that's the muscle that is responsible for pushing the baby out, right, during labor. And the muscle is called myometrium. Okay. And there's a hormone that increase the contraction of the myometrium. Okay? You might have heard of it before. It's called oxytocin. Sometimes they give you oxytocin to induce labor if they think it's time for the baby to come out. There is the symphysis pubis. You remember we learned about that last class, right? That is a little bit of a cartilage that connects the pubis bone, that is, at the front. The pubis is part of your pelvic girdle, right? You have your ilium on the top, right? The ischium at the back, that's what you're sitting on right now, and then the pubis at the front. So the two pubis bones join anteriorly through the symphysis pubis. There is the urinary bladder. And I think I mentioned this before, right? When a woman is pregnant and then the baby grow, the uterus gets bigger and it will push down on the urinary bladder, right? So pregnant women tend to need to go to the bathroom more often. Other things here, like this right there. If this is the urinary bladder, then what is this that I just highlighted?
Urethra.
That's correct. Okay, so urethra, urethra. And that here, that's the vagina. And there's one last label here. So as the baby grows in the uterus, again, it gets bigger, like obviously, right? But then it also gets heavier, okay? And so you gotta hold this uterus in place so it's not gonna, be like descending. It's not gonna be falling down, right? And pushes on other key organs. And so there is a ligament that holds it in place. And that ligament is called the round ligament. Round ligament. Okay. And as it stretches, when the uterus gets bigger, it kind of creates this. This is like based on what my wife told me, right? It feels like you have been doing a lot of exercise around that area, and it's like that afterburn that you feel. So like for the first pregnancy, we didn't really know about this thing. Right? So she keeps on complaining about this discomfort, like in the abdomen area. Then we went in and we thought she had like appendicitis or something, but turns out it's just a round ligament stretching itself as the uterus grows. So there we go. That's the female reproductive system. Any question?
What's above the urethra?
What's
Right.
about the urethra? Oh, this one? Oh, that's just the labia. Okay, so like over here, there are two skin flap of skins on the outside, on the external genitalia. So that's the minor labium and major.
I can
Labia.
fly a butterfly. I can take one.
Is that your daughter? Okay, so that's the yeah, just the two flap of skin. We don't have to label it. Okay, just the ones that we label here are suffice. Okay, that is that.
Professor,
Uh-huh.
can you go back to the one that you were labeling just now?
Sure,
My
sure.
God, my daughter's not giving me a chance.
Yeah, I know. That's okay. No worries.
Thank you.
Let me know when you're okay, and then we'll proceed. So one of the things we're not able to do on an online environment is like I can't ask you to label a diagram on the test, right? So it falls upon you to really learn the parts and make sure that you know it. Because I think a lot of you going into practical nursing, right? So you will actually learn all these things again in greater details when you move on to practical nursing.
Thank you, Professor.
Yeah, no worries. And so I told you, right, like after the course end, you won't have access to the course shell anymore. So if there's any notes that you like to keep, any links to any videos, make sure you copy all that before the end of the course. Okay, so let's take a look at this ovary. Like many other organs that we learned about, right? There is often an exterior portion and an inner portion. Okay, so like the kidney has the renal cortex and the medulla, right? The adrenal gland has the cortex and the medulla. Same thing for the ovary. Okay, there is the cortex on the outside, and there is the medulla. Now, in the outside, in the cortex, there are many follicles. Okay, so these follicles are basically they contain an immature egg that has been suspended in prophase number 1. Okay? So you learned about this last semester, right? Like females are born with all the eggs that they're gonna have in their entire lives, but they're all suspended in meiosis 1. So until puberty, then each cycle, one egg will continue to mature. Okay, and then wait for fertilization to occur. And that's what these follicles are. Okay, they contain immature ovum called an oocyte. Okay? And the female is born with as many as 2 million follicles but the number is reduced to, 300 to 400,000 by the time of puberty. So a lot of these follicles are reabsorbed by the body, or they are not going to be in use. Okay, so way more follicles than even if you start counting at puberty, right? Okay, there are way more follicles than the person actually needs in their lifetime. Okay, so that's what the ovary looks like. You have the cortex and the outside medulla here, and the hilus is where the ovulation kind of occurs, and it goes into the fallopian tube. So only a small number of follicles, as I was saying, right? Like even though you have hundreds of thousands of follicles, only about 400 ever completely mature, right? Because you only release one egg per month typically, right? When I say month, I use that term loosely, right? Most textbook will say 28 days cycle, but I'm sure you know it's not always 28, right? It could be as long as like 35 or sometimes shorter. It doesn't really, it ranges from person to person, right? So it's not necessarily a month, but typically there is one egg per cycle, right, in her reproductive years. And if you do the math, right, puberty is around 18, period comes a little bit earlier, and then menopause might be late 50s, early 60s. Well, you can figure out how many eggs are going to be released throughout the lifetime of the reproductive years, right? So roughly 400 eggs are ever going to be made from that 300,000, 400,000 stock. Okay? And since the oocytes, which is the immature egg that is present in the follicle, they were already there at birth, the oocyte the quality of the oocytes tends to deteriorate as the woman age as well. So that is one reason why older women are likely to are at higher risk of having kids with chromosomal defects, okay, because of the degradation of the DNA quality in their eggs. So this chart shows the incidence of trisomies. Trisomies is like an extra chromosome, right? With maternal age, and it just basically increases the risk exponentially. Okay, so that's why some you hear celebrities, right? If they could, celebrities, of course, they could afford it. But if a person can afford it, sometimes some people might choose to freeze their eggs, right, at a young age, and then use them later on in life to have babies. So this is some of the stuff that there's a question. Is that why some women go through menopause before some? Menopause is completely different. Menopause is more like a hormonal situation. It's not doesn't have to do with the quality of the eggs per se. Okay. So that is basically what I was telling you when I was labeling the diagram with you. I'm not going to read it to you again. You can just go through it yourself. And now I want to make a note. And this is a long note. It's probably going to take us like a good half an hour or so. So I hope you have papers, and hopefully you won't tire out the hand too much. What should we call this note? We will say hormonal regulation of female reproductive system. Okay. So I'll give you a moment to get ready. So before we talk about the female reproductive system, we actually have to do a little bit of background information. Background information on the brain of all places. Okay. So pay attention to this part, because this will be useful for next class as well. Okay. Now, hopefully by now, when you see me draw this, you know exactly what I'm drawing. Okay. We've done this so many times that you should know this is the hypothalamus. And what's the thing that's below the hypothalamus?
Pituitary gland.
Now it's hard to tell which one is anterior, which is posterior, depending which side your head looks, right? If you look that way, then the one on the right is anterior. If you look this way, then the one on the left is anterior, right? But generally speaking, in a diagram, the anterior pituitary gland is the one that's going to be look a little bit bigger. So that's this one here, okay? Anterior pituitary. You should draw the big one, okay? Because we're going to put a lot of stuff on this guy. And over here we have the posterior pituitary. Okay. Now I just want to double check to see if you remember. Don't draw this. But there is a bone, right? There's a bone that protects the pituitary gland, right? It has a little groove on top that protects it. Does anybody remember what bone that is? It's in the head. I give you a hint.
Sphenoid bone.
That's right, the sphenoid bone. And on top, there is a little groove, right, for the pituitary gland to sit in. Okay, very good. So, previously in the kidney unit, oh, by the way, like your kidney test is quiz is due today, right? I saw some of you did it already. Don't forget you have 2 chances. Okay, so if you haven't, do a second attempt. You know, feel free to do that. You will only the highest score will get recorded. So even if you get like 89, right, do it again. Maybe you'll get 99 next time. Who knows? So in the kidney unit, I was telling you that some hormones are made in the hypothalamus and store and release from the posterior pituitary gland, right? So there's like a physical connection between the hypothalamus and the PP because the neurons actually physically extend their axon into the posterior pituitary. So the hormone that we gave as an example was ADH, right? Anti-diuretic hormone. Now I'm going to give you another one because I mentioned it earlier today. That's oxytocin. Okay, oxytocin is responsible for contraction of the uterus, right? During labor. So these hormones are made in the hypothalamus. They will be transported down the axon in little vesicles, which will be then stored in the PP until they are needed. So when do you need ADH? When you are dehydrated, and that will trigger the release of ADH from posterior pituitary. When do you need oxytocin? When you're giving birth or when you're nursing your baby, right? Then it's going to release the oxytocin. More on that next time. But I'm just trying to illustrate to you that some hormones are made in the hypothalamus and then stored and released from the posterior pituitary gland. Now, the anterior pituitary gland is completely different in the sense that they are not relying on the hypothalamus to supply hormone. Instead, they make their own. Okay, so there are a bunch of hormones that are made in the anterior pituitary gland. But for today, we will be focusing on 2 particular ones. Okay, one of them is called the follicle stimulating hormone. And it's good to know what they stand for because it usually tells you what it does. So that's the follicle stimulating hormone. And then there is the LH, which is luteinizing hormone. Okay, so these are made in the anterior pituitary gland, and it stored there until it is ready to be released. Now I'm just gonna give you like a brief overview. We'll go into more detail in the endocrine system. But the hypothalamus have an other set of neurons. These neurons, instead of extending all the way to the pituitary gland, they kind of stop short here. Okay. And from there, they are going to be releasing controlling hormones that will regulate the anterior pituitary gland. So there are two kinds of hormones that they could secrete. Okay? They could secrete red ones, so to speak, and they could secrete green ones. Okay, so the green ones are called releasing hormones. Okay, and these releasing hormones will be green lights for the anterior pituitary. Okay, so it will tell the anterior pituitary gland to release some hormone. It's like, okay, I give you permission to do so. Sometimes you don't want them, then you have the red light, which are the inhibiting hormone. Do you understand? So each of the anterior pituitary gland, each of the hormones in the anterior pituitary gland will be regulated by its own set of releasing and inhibiting hormone. Okay, so there are more anterior pituitary hormone, right, that we'll learn next time, and each one of them will have their own signals for releasing or not releasing. Okay, and that signal comes from the hypothalamus. You guys with me? Any questions? All right. So remember, relationship between hypothalamus and posterior pituitary, physical connection. Okay, it's like I mean, people don't use DVD players anymore, right? But then like DVD players or like Blu-ray player, you need to physically plug in the cable, right, to your TV, right? Okay, like a HDMI cable that you connect whatever device you have physically to the TV. That's what this is. Okay, the relationship between hypothalamus and anterior pituitary gland, that's like Wi-Fi. Okay, you don't need to have a physical connection. Okay, you just send some signal there, and then you can control it. Okay, and the signal comes in the form of releasing hormone and inhibiting hormone. Okay. Now we won't be learning about the inhibiting hormones. Okay, we're just going to be focusing on the releasing hormone. And an example of releasing hormone is called GnRH. Okay, gonadotropin releasing hormone. We'll write that down later. But that is the permission for the anterior pituitary gland to release FSH and LH. Okay, so GnRH, which stands for gonadotropin releasing hormone. Again, like memorizing the name is like optional, but then like knowing what they stand for probably will tell you what it does. Sorry, gonadotropin releasing hormone. It's a releasing hormone that has something to do with the gonads. Gonads are like ovary and testis, right? So the GnRH stimulates the AP, anterior pituitary, to release FSH and LH. I'll tell you what they do in a bit, but that's the background information so far. I'm just gonna let you catch up. If you have questions, please feel free to ask.
Professor, is that a U beside the G? G-U-R-H?
Oh, GNRH, yeah.
Oh,
GNRH. There we go. Okay. Next, we're gonna talk about the ovaries. The ovaries. And we're gonna draw a nice ovary right here, big one, huh? Don't do tiny diagram. You won't be able to fit all the information in. Then I'm gonna have a thing here. What is this thing that connects to the ovary?
fallopian.
Fallopian tube.
That's right. That's the fallopian tube. Okay. So again, this is very simplified version. Right, it's the whole process is very complicated, but we just can keep it simple. Okay. We have the follicle here. Follicle contains an immature egg, and one follicle will be chosen each cycle to become a mature egg. Okay, so it's going to develop, okay, and it's going to become mature. Okay, so this phase here, okay, if we assume the cycle is 28 days, this would happen during the first 14 days. Okay, so this is called the follicular phase. Okay, so this is 1 to 14 days. Again, I'm just going with the 28 days as an example. Okay. So follicular phase, what's happening during the follicular phase? The follicle develops. Right? And the egg matures. Okay. Let's do an educated guess here, people. We have two hormones, the FSH, which stands for follicle stimulating hormone. We wrote that down already. And then there's LH, which is luteinizing hormone. Which hormone, FSH or LH, do you think will encourage this process, will encourage the follicular phase? Is it the
FSH?
Yeah, because the name tells you so, right? It says follicle stimulating hormone. What does the follicle stimulating hormone do, right? It stimulates the follicle, right? So under the influence of FSH, the follicle will be stimulated, it will develop, okay? And then as the follicle develops, it is going to be releasing estrogen. Okay. So during the follicular phase, the estrogen level in the blood will slowly increase. When the egg is mature, then it will be released into the fallopian tube. This is called ovulation. Ovulation. Okay. Excuse me. Now, after the egg is released into the fallopian tube, after ovulation, there are some left behind tissues from the follicle. Okay, so this is left behind tissue. Egg is gone. Now I have some left behind material. This is called the corpus luteum. Okay, so left behind tissue. From follicle. After ovulation. Right? Now this thing, the corpus luteum, is going to grow a little bit more. Okay, so it gets bigger and then bigger. And then if pregnancy does not occur, then it will shrink and then it will be broken down. So that takes another 14 days. Okay, so this is going to be called the luteophase because it's dominated by the presence of the corpus luteum. Luteophase. And that would be like 14 to 28 days, right? I realize that that's not the right way to say it. It's like day 14 to 28, right? That's probably more appropriate. Because the other way sounds like it's going to take 28 days, right? That's not what I meant. So this is day 1 to 14. And then ovulation would be, you know, on day 14, like midway. Okay. And we're going to have another hormone that's being produced by the corpus luteum. Okay, that hormone is progesterone. So that's some background information about the ovaries. Questions? Anyone? Okay. So let's take a look at the actual hormonal regulation. So we're going to be looking at these diagrams. I'm just going to copy one over. Okay. At the beginning, right? At the beginning, what marks the beginning of the next cycle? That would be the menses, right? Okay, like the menstruation, basically. Okay, so I'm gonna put here menses. Menses marks the beginning of a cycle. Okay. So then what happens after the period starts? On a hormonal level, right? The hypothalamus releases GnRH. Hypothalamus releases GnRH. And then what happens? Well, GnRH is the green light for the anterior pituitary gland to release FSH and LH, right? So following the release of GnRH, right, number 1 here, the anterior pituitary gland releases FSH, and actually LH as well, but not as much. So I'm going to put like tiny letters here. So releases FSH and LH. Okay. So this is like just a network of capillaries, right? When the hypothalamus releases the GnRH, it could travel quickly through the capillaries to affect the anterior pituitary. Okay. And then you pump out FSH and LH. But at the beginning, it is the FSH that is dominating. What happens next? Okay, at number 2, okay, the FSH travels through the bloodstream to the ovary, and FSH will stimulate a follicle to develop, right? So that's what this is. This is a follicular phase, right? And I told you already, as the follicle develops, estrogen is released from the ovary. Okay. And then the estrogen does 2 things. Okay? The estrogen will have 2 actions. Right? Number 1, it will travel back to the brain, okay, and increase GnRH secretion from hypothalamus. Okay, this is called positive feedback. Okay, just pause for a second. Let me explain to you what that means. Okay, I told you when we first learned hormone that most of the hormone, their effect is going to be opposite to their trigger, right? This is called negative feedback, right? So take aldosterone, for example, right? You have low blood pressure, that triggers the RAS, which then releases the aldosterone, and then that will bring the blood pressure back up, right? So the end result, increasing blood pressure, is opposite to the trigger, decreasing blood pressure, right? Same thing for ADH. You have you're dehydrated, your water level is down, and then ADH helps you conserve water, which brings it back up, right? So that's opposite effect, negative feedback. Most hormones are like that. You know, say like 95% of the hormones in the bodies are like negative feedback. But in here, we have an example of positive feedback, where the end result of the hormone will reinforce the trigger. So let's trace back. What causes the estrogen to be produced? Well, if we trace it back, initially it was the release of GnRH, right? So increasing GnRH causes FSH to increase and then causes estrogen to increase. But when you have the estrogen, it actually goes back and tells the body to make even more GnRH. So in a positive feedback, the hormone will exaggerate the initial trigger instead of counteracting it. I will give you another example. Oxytocin, I told you, is important in labor. So when the uterus contracts a little bit, right, you try to push the baby out. That actually causes you to release even more oxytocin from the brain, and then it will go back and create even more contraction. More contraction makes even more oxytocin, which in turn creates even more contraction. And it just loops back on itself to keep on exaggerating the effects, right? And that's what you want when you are trying to give birth, right? You want more and more contraction to occur until the baby comes out, right? So that's another example of positive feedback. Okay, so the estrogen will go back to the hypothalamus and it will cause the even more GnRH to be released. Okay, Secondly, the second effect of estrogen is that it will cause the thickening of endometrium. Okay. So in preparation for potential pregnancy, the blood vessels will start to form in the endometrium, right? Just in case there's pregnancy and there's implantation, you need to have all these nutrients to support the growth of the baby, right? So it's going to get thicker and thicker and thicker. Okay, the lining of the uterus, that is. So all this stuff is happening during the follicular phase, the first half of the cycle. Questions, anyone?
So 4 and 5 are not part of the follicular phase?
No, 4 and 5 would be I'm gonna get to that. Yeah. All right. So let's do that right now. Okay, so what's going on F4? So after the estrogen goes back to the hypothalamus and then you release more GnRH, right? So then what happens? Well, it's basically the same thing. The anterior pituitary gland will release FSH and LH, but this time, like the second round, right? LH is the one that is going to be playing a key role here. Okay, so number 5, right? And increase in GnRH from the positive feedback will trigger anterior pituitary to release FSH and LH. It's both, but then the LH is the dominating hormone this time around. Okay. This results in an LH surge. That is a sudden, sharp increase in LH in the blood, right? Because these hormones are released into the blood. Right? Is that number 4? Sorry, that was number 4. My bad. Number 4 here. So that leads to an LH surge, and then it's going to be number 5 right here. Pull the diagram a little bit down so we can see it. Okay, so following the LH surge, which travels through the bloodstream to the ovary, right, it would trigger an event at number 5. LH surge triggers ovulation. Okay. So that's like middle of the cycle, right? If the cycle is longer than 28 days, then ovulation occurs like 7 days before the next menses, right? But it's hard to time sometimes, right? Because you never know when it's going to come, right? So it's like hard to work backwards in some cases, right? So that's why there are these ovulation kits that you can buy. Okay, so what hormone do you think the ovulation kit detects? If you're trying to see when ovulation is happening, what hormone do you want to check?
Estrogen?
Sorry, which one?
Estrogen? Okay, progesterone then.
Actually, it's LH. Actually, it's LH, okay? Because it is the LH that triggers the ovulation, right? The surge, the sudden sharp increase in LH is what's triggering the ovulation, okay? So like from what I read, this is how the ovulation kit works. Okay, you have to test your urine continuously. Like I think like I don't want to presume, but I think like women usually have an idea of when ovulation could happen, right? Like it's around certain times, okay, but they're not sure like exactly what days, right? So like when it's close to the ovulation day, then they would basically test their urine, okay, with the ovulation applicator. I think I'm not sure what it's called, okay, but that there is that like a stick, I think, okay, and on it are actually antibodies that will recognize LH, okay. So you have to do it on consecutive days, because how it works is that it will compare the LH level of this sample with the one you had yesterday, okay? And then day 3 you have another sample, and then we'll compare with the ones on the previous day. And what it's trying to look for is a sudden drastic increase, okay? So like day 1 maybe there's like 10 units of LH. I'm just making this up, okay? Day 2, 12 units, okay? 11 units on the third day, and then all of a sudden it becomes like 30 units, right? Then it will tell you, okay, ovulation is already here, or it's going to be happening like later today or tomorrow. Do you understand what I mean? Okay, so it's not about whether you have LH or not. That's why one sample is not enough. Okay, the kid has to test for consecutive samples and see when there is a sudden sharp increase. Make sense? So this is important information for pregnancy planning, right? Like if you try to get pregnant, or if you try to avoid getting pregnant, this information is critical. Okay. Any question at all about any of these hormone stuff? We're still only on the first half of the cycle, by the way. Okay, great. Second half now. So after ovulation, right? What does the follicle become? Do you guys remember? We wrote it down. Just want to check to see if you were with me.
Corpus luteum.
That's right, the corpus luteum, right? Okay, which is shown here by this yellowish thing. This is the right. I think this is the right one. Or this is the left. I can't really tell. Looks kind of weird here. I think this might be the right ovary. Okay, doesn't really matter. What does matter though is that the corpus luteum will form. So that would be number 6. Okay, number 6. Let me just zoom in again. I told you I have a tendency to keep on writing bigger and bigger. Let's go back here, number 6. Okay, so the corpus luteum forms after ovulation. Now it's not like a new structure, okay? Like it's just the leftover material from the follicle, right, from before. And the corpus luteum is a transient structure. It's not going to stay here forever. It's going to get broken down after a while, okay? So corpus luteum forms after ovulation, and it secretes progesterone. Okay. 7. Progesterone has 2 effects. Now, if you are producing progesterone, that means you already have an egg in the fallopian tube, right? So it doesn't make sense for the body to create another egg at this point. Right? We don't need another follicle to develop because we already have an egg in the fallopian tube. So one of the effects of progesterone is to decrease or inhibit GnRH secretion from hypothalamus. Okay. And if you lower GnRH, because that was the green light for FSH and LH, right? If you lower that, essentially you turn off the green light, then that would result in a decrease in LH and a decrease in FSH, right? Which again is what you want, right? We don't need more FSH. We already have the follicle developing. Sorry, we already have the egg in the fallopian tube. We don't need another follicle developing. Okay, there's no need for more LH. Ovulation already occurred. I don't need another surge. Okay, so this is negative feedback. Okay, you're shutting it down rather than encouraging more, right? So estrogen was positive feedback. Progesterone is negative feedback.
So, Professor, it turns off the LH and FSH, or it decreases it?
It doesn't shut it down like completely. You will always have some like baseline level. But the key is it actually turns off the GnRH, which in turns lowers the FSH and the LH.
Okay.
And then the second one is it will further thicken the endometrium. Okay. Again, I am repeating the same thing over and over again. The egg is in the fallopian tube. That is where fertilization is supposed to happen, right? So your body is anticipating a potential pregnancy, okay? Which means you need to get the endometrium ready. So it further thickens the endometrium. All right. So let's talk about what happens next. Most of the time, pregnancy does not occur. Okay. And then, so no pregnancy. Okay, so no pregnancy. What happens? If there's no pregnancy, then corpus luteum breaks down. Without corpus luteum, I want you to think this through, okay? Without corpus luteum, what hormone goes down?
Progesterone.
That's right, you have decrease in progesterone. Listen, what happens if progesterone goes down? Then these two things will no longer happen, right? Okay, so once you turn down progesterone, there is no hormone sustaining the endometrium anymore. So all that new blood vessels that was formed, right, to thicken the endometrium is no longer sustained, and they all shed. And then what happens? And we go back to the beginning, right? Menses. Then that starts the next cycle, right? So the drop in progesterone causes the shedding of the endometrium, which starts the menses, right? Does that make sense? So decreased progesterone, okay, no longer sustain the endometrium. That leads to the menses. More importantly, progesterone was suppressing GnRH, which in turn cause LH and FSH to be lowered, right? But now pregnancy did not occur. The egg is gone. It's time for another egg, right? So when you decrease the progesterone, not only does the menses occur, but now you will increase GnRH because the suppression is no longer there, right? And if we go back to the beginning of the note, you can see after, like the menses, after it happens, then hypothalamus releases the GnRH because the progesterone negative feedback is no longer there. Any question at all? I feel like I'm not doing a good job explaining here. Sorry, any confusion? Okay, great. So that's what happens when there is no pregnancy, which again, right, it's the usual course of outcome, right? Okay. And then the next cycle, and then the next cycle. But pregnancy could happen as well. So what happens when pregnancy happens? Okay. So when pregnancy happens, the fertilized egg will implant into the uterus, and the placenta will start to develop, right? Okay. So as the placenta is developing, there is a hormone that gets released. It is called the HCG. Okay, HCG, human chorionic gonadotropin. It's in the PowerPoint. Okay, we will look at what it stands for later on. Okay, but HCG. So HCG will sustain the corpus luteum. Okay, it's very important to sustain the corpus luteum if you're pregnant, if you have the implantation, if the egg is fertilized and then it's already in the uterus, you cannot let the corpus luteum break down. Why? Because if the corpus luteum break down, then there is a drop in progesterone, and then the endometrium will shed, right? But the egg is implanted in the endometrium. You can't let that happen, right? So that's why the HCG is important to sustain the corpus luteum until placenta. Placenta is the structure that connects the mother to the baby, right? Baby to the mother, until the placenta is formed. Okay. Once the placenta is formed, the placenta will create its own supply of estrogen and progesterone. Then you don't need the corpus luteum anymore. Okay. So pregnancy kit, they test for HCG. Okay. If you have HCG in your urine, which means it's in your blood, then it's pregnancy. Okay. So that is that. We will look at the graph afterwards. So this is what I was talking about, right? The human chorionic gonadotropin. Tropin means it's attracted to. So this is a hormone that's like affecting the gonads, basically. Causing the corpus luteum to stay there until until the placenta begins to produce its own progesterone and estrogen. And actually HCG will continue to be high throughout pregnancy. All right. All right, let's just do a few quick polls here. Yeah, this one pretty straightforward, right? Philippian 2, very good. Let's do this one. Okay, it's both estrogen and progesterone, right? So estrogen starts the process in the follicular phase, and then progesterone kind of adds on to it in the luteal phase, right? So both. Okay, let's try this one. Yeah, everybody got it. Okay, decrease FSH and decrease LH. Excellent. Okay, it also decreases GnRH, right? Okay, this one, see if you were paying attention. Okay, so I see that people are getting confused between HCG and LH, okay? HCG is for pregnancy test, okay? LH is for ovulation test, okay? The surge in LH is what triggers the ovulation. That's the hormone that you need to test for, okay? HCG, again, pregnancy test. Okay, that's it. I read an article, okay, like the boyfriend was like peeing on the pregnancy test of his girlfriend, I think, just for fun, right? Okay, and then he tested positive for HCG, and that's actually bad news. Okay, if a man shouldn't have HCG, and if they do, it turns out the guy had testicular cancer. Okay, so the cells has mutated and they start producing this HCG. So it could happen in some cases, and it's usually not good news. Okay, maybe we should take a break. We've been talking for quite some time. 5 minutes, and then when we return, we will look at this chart here.
Professor,
Yeah.
when you take the break, can you put the computer screen on the
This
the
one?
ovary, on the ovaries that you drew?
Oh, this one?
Yes, please.
Sure.
Thank
No
you.
worries. All right, see you guys in a bit. Okay, let's keep going. Now, why don't I do the chart with you to try to explain this situation over here. Okay, so like it looks a little bit different than this one. Like the peaks and the valleys might be a little bit off, but all these graphs, which you will find in every single textbook for the reproductive system, they convey the same kind of information. Okay, so I'm just gonna use this one as a template to show you what's going on. I probably should update this one. This one looks really old. In any case, over here, we have the follicular phase. Okay, that's like the first half, right? The first half of the cycle. Follicular phase. Okay, and then the second part, that's the luteal phase. Okay. Excuse me. So the follicular phase, how does it begin? Well, it begins with the FSH and the LH, right? So you have your increase in GnRH, and then your FSH and your LH is going to increase. Okay, so over here, this we'll color them, I guess. Right here, that's gonna be the FSH, follicle stimulating hormone. And then this one over here, that's gonna be the LH. Right, so what happens is during this part here, you would have increased GnRH, which causes the LH and the FSH to increase from their previous level. And that causes the follicle to develop, right? And as the follicle develops, you can see that this hormone keeps on going up, 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 up. So what hormone is that? What is this green hormone right here?
Estrogen.
That's right, that is the estrogen. Okay, as the follicle develops, the estrogen increases, right? So increase in estrogen during the follicular phase. And take a look at this, the endometrium, right? The endometrium gets thicker and thicker and thicker as the estrogen gets higher and higher and higher and higher, right? Okay. Another thing to notice is here. I'm going to put a star here and then put a star here. After estrogen peak, after estrogen level peaks, LH surge occurs, right? Because remember, the estrogen goes back to the hypothalamus, and then it increases the GnRH through positive feedback, which then leads to the LH surge, right? So you can see in this graph, the LH surge corresponds to the timing of ovulation. Okay, LH surge occurs, followed by ovulation. Okay. As soon as ovulation occurs, though, the follicle is no more. It turns into the corpus luteum, right? So that's why the estrogen declines immediately after. With the decline of estrogen, the LH surge is over. Now that we have the corpus luteum, which is what this stuff is, okay? This is the corpus luteum. With the formation of the corpus luteum, now we have a second hormone that is going to increase, right? So I'm sure you know this one is the progesterone, right? Progesterone was virtually not there at the beginning because the corpus luteum hasn't formed yet, right? Now remember, progesterone has a negative feedback mechanism. So as progesterone increase, you can see over here, we have a drop in LH and a drop in FSH because progesterone is suppressing them, right? As well as suppressing the GnRH. So everything is down, down, down here. but the endometrium will continue to thicken because of the progesterone. If there's no pregnancy, the corpus luteum breaks down, then progesterone drops, endometrium shreds, and then the next cycle begins. Any question? Okay, let's go back to this PowerPoint thing. Male now. Oh, let's label the male reproductive system. Where is that? It's probably higher up. Nope, it's lower down. Right here. So that is the front view of the male reproductive system. We have the we have the two tubes here. Okay. That is coming from the kidneys. And so those are the ureters. Okay. And of course, the ureters are going to be connected to this thing right here. Okay. That's the urinary bladder. All right. That's a urinary bladder. Over here, below, actually kind of in front of as well, the urinary bladder is going to be this gland right here. That is L, and we call it the prostate gland. Okay, so the prostate gland secretes a milky basic solution that helps mix the semen. Now, there are two other glands that contributes to the volume of the semen. And here's another pair of glands here. Those are called the seminal vesicle. Seminal vesicle. We'll talk about them in the PowerPoint slides. And then the last gland that contributes to the semen is M, which is the bulbal urethral gland. Okay, also called Cowper's gland. And then here we have another one. We have another tube right here. You should know what that is. It's the urethra. Okay, of course, it keeps on going, right? But like they stop here. Okay, so let me put a few stars here. Seminal vesicle, prostate gland, bulbal urethral gland. They contribute to semen volume. Okay, most of the secretion are basic, as in like high pH. Okay, because the vagina is acidic, right? It's low pH there. So you need to neutralize the acidity, otherwise it would kill the sperm. So there are two tubes here that carries the sperm from the testicles all the way to the urethra, right? So these are called vas deferens. A man can choose to have vasectomy, where they would cut the vas deferens, and they basically will have no sperm in the semen. So that's a procedure that can be done if they don't want to have babies. All right, next here, K. It's a little bit hard to see, but let me zoom in a little bit. There are these ejaculatory ducts. They are surrounded by smooth muscles, which contracts to expel the semen during ejaculation. Couple other things here. Those are the, of course, testicles or testis. And we have this thing over here on top of the testicles. That's called the epididymis. That's where the sperm has swimming lessons. That's where they learn how to swim and become mobile. And it's also kind of stored there until it's released. All right, so the sperm are made in the testis, stored in the epididymis. When it's time to come out, they will go through the vas deferens, okay, and then through the prostate. The prostate is like a circular structure, okay, and I guess think of like an orange, okay, and then you poke a straw right through it, right? That's basically what's happening here. Okay, so the urethra is passing through the prostate, and then it connects with the urinary bladder behind, right? Okay. So that's the anterior view. I'm going to show you the side view, and hopefully things are a little bit more clear from this perspective. So let's start with this one.
Professor, what was A?
A, where's A? Oh, vas deferens. That's the tube that carries the sperm from the epididymis to the urethra. Okay, there are two of them on each side. Okay.
Thank you.
Yep. So this is a different A now, different diagram. That is the urinary bladder, right? Urinary bladder. Now there is that bone again, cartilage instead, actually. Symphysis, pubis. Yeah, so try to see here, right? That's the blue thing here. That's the urinary bladder, and then the prostate gland is right there. Prostate gland. So there it is. Just try to color it for you. So the prostate gland, men over 40 are recommended to get their prostate examined, during physical checkup. Okay, so if it's enlarged, then the physician can actually feel the enlarged prostate through the rectum. Okay, so that's something that they should check for. because enlargement of prostate can mean a bunch of bad things, okay, including prostate cancer. Now there is the seminal vesicle. There are two, one on each side. Okay, so you can see the seminal vesicle right here, right? Kind of at the back of the prostate. And there is the bulbourethral gland, which is right here. Okay. K is the urethra. I can probably trace that out for you right there. This is black line in the middle. Couple other things here. J, I, H, I, and J. You know, all of these is pointing at the epididymis. Okay, I'm just gonna color the whole thing here for you. Right here, epididymis. Okay, it's like separated into the head and the tail and the body of the epididymis, but it's okay. We can just call it epididymis. Okay, and again, that's where sperms are going to be fully mature, becoming motile, gain mobility, learn how to swim, right? And then it's going to get stored there. And here is the testis. Couple other things here, and then we're done. There is that. And then there is that. Okay. So that is called the corpus. Corpus just means a bundle. Corpus cavernosa. A bunch of cylindrical structures. Okay, and then at the ventral side of the penis, there is the corpus spongiosum. So these structures gets filled with blood and creates the erection. Corpus cavernosum and spongiosum. That's the head of the penis, is called gland penis, and it's covered by the foreskin, but it's actually called prepuce. Sorry, prepuce. And you know, some people undergo circumcision and they remove that. That's it. Any question? Okay. I mean, you can take a look at this. This is pretty much similar to what we have in diagram. You know, you can mix and match the terms and see what they look like in a different diagram. So let's take a look at the testis. Testis, TIS is singular, testes are both, okay? And you can also call them like testicles, right? Same meaning. So the testis contains tightly coiled seminiferous tubules. packed with cells undergoing spermatogenesis. I'll show you what I mean by that. Okay, so these seminiferous tubules. Now there are some cells called interstitial cells. They're going to be found between the seminiferous tubules, which help secrete the testosterone. Okay, so the testosterone is like the male version of the progesterone, right? The analog of it. Okay, and within the seminiferous tubules, there are the germ cells that will become the sperm if they do spermatogenesis, and then there are these Sertoli cells which will help support and nourish and regulate development of cells undergoing spermatogenesis. In other words, they support the germ cells. Okay, so the best analogy I can think of in terms of visualization is instant noodle. Okay, now you will never look at instant noodle the same way. Okay, the seminiferous tubules is exactly like that. Okay, trust me, it's all coiled up and then it's all bundled together, and then there is some space between them. Okay, so let's try to draw that to help you understand a little bit better. Okay. I guess we'll go back to our note here. Okay, so here we go. This is the testicle. Testis, sorry, testis. And that would be the epididymis, right? And so the testicles are actually separated into little sections. If you were in my class, I showed some of you like bunny testicles, right? Under the microscope, you might remember seeing that. You guys had a good laugh when I show you that one. So these sections inside are basically the instant noodle, the seminiferous tubules, like that. Okay, so those are the seminiferous tubules. Okay. I'm gonna pull one of these things out, okay, like that. Okay, so it's just a tube. And in the seminiferous tubules, you would have these germ cells that are kind of on the periphery. These are the germ cells. And then they will undergo meiosis, and as they mature, they go towards the center of the tube. Okay, and then under the microscope, you can actually see the tails of the sperm. Okay, so when the sperm is fully mature, they will break off from the walls of the seminiferous tubules, and then they go into the center, and then it will travel all the way to the epididymis. Can you guys visualize this? I remember when I was in high school and they showed this tape for like sex ed, and I think it was like the Discovery Channel they made, or maybe it was TLC. Anyway, you can probably look that up on YouTube, and it was like the most memorable thing I saw related to sex ed. There were all these people dressed up in like white suits, and then they wear like white caps. They're supposed to be the sperms, and they were just like sliding down these water slides. Okay, thinking back, now I understand what it represents. It's the seminiferous tubules. Okay, the sperms literally slide through all these tubes, and eventually it gets to the epididymis. Okay, and then they're going to stay there, and they're going to continue their maturation, and basically until they are released, they will be there. Okay, but the germ cells are going to be on the edge of the seminiferous tubules, and they will, as they mature, they will move towards the center, which is hollow, and then when they're fully mature, they will break off, and they will follow the tubes and the tube system basically until it gets to the epididymis. Any questions so far? Okay, so like the tubes, I'm just gonna try to just draw more tubes. You don't have to draw this, you can just watch me do it, I guess. Right, so they're all coiled up, right? Like the ramen. Okay. And it's one continuous tubes, okay, that goes all the way eventually to the epididymis. Okay. And in between the seminiferous tubules, there are some space. And in those space, that's where you will find these, interstitial cells. Okay. And they secrete testosterone. Okay. And testosterone will help promote spermatogenesis. Now, there are also these Sertoli cells that I didn't draw. Just gonna draw them right now. They are also in the seminiferous tubule. Okay, and their job is to support the germ cells, right? Nourish them, regulate the development, controlling the spermatogenesis. Okay, that's pretty much it.
Professor,
Mhm.
does each cone have its own interstitial cells, or is it just one?
Oh yeah, they have their own. It's like all over the place, right? So like interstitial cells everywhere, everywhere. Okay. Oh, that was the wrong color, but you get what I'm saying, right? There we go. Okay. Let's take a look at the professional drawing. There it is. Okay, so you can see it totally looks like ramen. And then we have the the sections. They're actually called lobules. And when you take a look at them under the microscope, all these are like actually sperm cells, the tails. Okay, and then you have the interstitial cells between them. Okay, so like the germ cells, the less mature ones will be concentrated on the outer edge, and as they mature, as they undergo meiosis 1, meiosis 2, they move towards the center of the seminiferous tubules. Okay, and ultimately they all get to the epididymis, and then from the epididymis, remember there was the head and the body and the tail, right? They will move down to the tail when it's ready to come out, and then go all the way up to the vas deferens. And there are 2 vas deferens, right? That goes on each side. So from the vas deferens, it will join, the 2 vas deferens from both sides will join to form the ejaculatory duct, which passes through the prostate, right? Like the straw through the orange I was telling you. And then in the prostate, it will connect with the urethra. Urethra, of course, passes through the penis, and then it will transport the sperm to the outside. And of course, the urethra is shared between the urinary system and the reproductive system. Okay, both urine and sperm comes out through the urethra. Okay, which is why you also need the semen fluid to be a little bit basic, because urine can be acidic sometimes, and that acidity could kill off the sperm. Oh yes, there was this article that I saw. It was like this man in Iowa in US. He wanted to do circumcision, okay, removal of the foreskin, but somehow there was some miscommunication with the doctor or something, and he ended up getting a vasectomy afterwards, right? And he was angry, like understandably, right? Those totally 2 different things. Okay, you become sterile if you do a vasectomy, although it's reversible, but still. Okay, so then he sued the doctor, and then the judge gave him $1 million award, right, for this messed up. So I was reading this article on the bed at night, right, and my wife was sitting next to me, and then I show her. I was like, man, for $1 million, I would welcome a vasectomy, no problem. Cut both of the vas deferens. It's fine. But you know, it was a big deal for that person, and you know, he got compensated for the mistake. Anyway, this is the seminal vesicle that I was telling you about, and they are located at the back of the urinary bladder, and that is going to be secreting a majority of the semen volume, up to 60% of it. Okay, slightly basic for the reason I told you about, and it contains fructose to provide energy for the sperm. Okay, so once the sperm leaves the male body, right, there's no nutrient supply for them. They have to swim a long way to meet the egg, right? They go into the vagina, they go up through the cervix. Okay, half will go one way, the other half will go the other way. They don't know which way the egg is coming out from. Okay, it's not like both ovaries release the egg, right? Each cycle, only one egg comes out from one side, right? So automatically 50% of them is going to be gone, and then the remaining half still have to swim up all the way to the fallopian tube to find the egg, right? And all this is happening against gravity, right? They have to go upwards, right? So it's very consuming process, energy consuming process. It requires a lot of nutrients, and that's what the fructose is for. Okay. The prostate is located below the urinary bladder, and it's not too big, size of like a typical walnut, and it encircles the urethra, again, the straw through the orange, and it secretes additional alkaline fluid. Alkaline means basic, pH higher than 7. Okay? And this mixture helps enhance the motility of the sperm, allows them to move quicker, move faster. The bulbourethral gland is the Cowper's gland, same thing. Okay, very small. It's just located at the back. It's not shown here, but you know, those are the tiny ones here. And if it's supposed to be shown, it will be located about right here, just a tiny gland. And they secretes the also alkaline mucus in response to sexual stimulation. So that actually helps lubricate the penis for intercourse, but also the fluid actually comes out a little bit before the actual ejaculation, and that helps flush the urethra. Okay, because like I said, urine could be acidic, right? Although it sometimes could be basic as well, depending on your H plus and bicarbonate absorption and secretion at the proximal tubule, right? Excuse me, but you do want to flush it out before the sperm actually comes out. So regulation of sperm production, pretty straightforward. It's definitely much easier than the female regulation here. So at the start of puberty, the hypothalamus increases its production of GnRH. So male also has GnRH, and that will stimulate the anterior pituitary gland to produce FSH and LH, right? So FSH is named after the function in female, which is follicle stimulating hormone, stimulates the growth of the follicle, but there are no follicles in male. So instead of doing oogenesis, which is what follicle development essentially is, FSH will promote spermatogenesis. Okay, so if you think back to the female reproductive system, right, the LH is going to create the LH surge and then ovulation, and then afterwards you start to produce progesterone, right? Remember that? Let me just go back here to show you the graph. Look here, after the LH peaks, then progesterone start to go up, right? Because LH essentially trigger ovulation and creates the corpus luteum. And I told you the male analog of progesterone is testosterone. So LH promotes testosterone production. Okay, I'll summarize all this in the table for you in a bit. When testosterone level is high enough, right, it's going to go back to the pituitary gland and suppress GnRH and LH production. Okay, because you know you don't need to waste resource to make more sperm. If you have adequate level of testosterone, that means spermatogenesis is going quite well at the moment. You don't need to make more, so you would have a negative feedback there. Okay, as testosterone levels begin to fall, then you lift the negative feedback, and you will increase GnRH secretion again, and then which would lead to, you know, LH increase once again. So it's the same kind of delicate balance that you see in the female reproductive system. Here's a picture that shows you what it looks like. So hypothalamus secretes GnRH. That causes the anterior pituitary gland to produce FSH and LH. FSH will stimulate spermatogenesis, and then LH would stimulate the production of testosterone. Those interstitial cells, they have another name called Leydig cells, but we're just gonna call them like interstitial cells. Interstitial cells, and they will produce the testosterone. Okay, and they will also encourage spermatogenesis. With an increase in testosterone, it goes back and then it lowers GnRH and lowers the production of FSH and LH, much like progesterone would, right? So that's basically the path. And that's it. That's the end of the lecture. Isn't it great? Let's go through these PowerPoints. These are poll questions very quickly. Fructose-rich secretion is produced by which one? Which one is it? Where's the poll? There we go. That's right, it's the seminal vesicles. Very good. And the last one here. Vasectomy will result in semen with no sperm. Okay, semen with no sperm. Okay, because then you cut off the source of the sperm, right? It's not gonna come out. Not all of the above. Okay, like the others, like erectile dysfunction, it's like not able to have an erection. That has nothing to do with the vas deferens. Incontinence is not able to like hold your urine. And that again has nothing to do with the vas deferens. The ejaculation will still occur. It's just that the semen that comes out only contains secretions from the prostate gland, seminal vesicles, and bulbourethral gland. There will be no sperm in it. And that's it. That's it. Okay, short lecture, shortest lecture of the whole course, I would say. But still, like, a lot of information that you have to know. Let's fill in the table here, and then I'll send you on your way. Yeah, probably will still go close to 11 by the time we finish filling this up. It's gonna be 11. Okay, so because there's a slight difference between male and female, I'm gonna use black. If it's the same answer for male and female, and then just gonna use red and blue to distinguish different functions in the male and female, if need to. So GnRH, gonadotropin releasing hormone. Where is it from? Does anybody remember? Where do we release? Where do we secrete GnRH?
Anterior pituitary gland.
That would be the target of the GnRH. But where is GnRH?
Hypothalamus.
Hypothalamus. That's right, hypothalamus. Very good. So it's the same for both gender. We'll put hypothalamus. Stimulus. Now that's different for men and female. For female, the stimulus for GnRH is actually decrease in progesterone, right? Because progesterone suppresses GnRH during the luteal phase. Okay, so if you decrease the progesterone, then GnRH will be released. Or it could be an increase in estrogen. That's going to increase GnRH through positive feedback, right? For men, what would be an increase? What would be a stimulus for GnRH? What hormone do we have? Do we turn that? Lowering which hormone will increase GnRH?
Testosterone.
That's right, testosterone. Effects on target. Does GnRH do different things in male and female? Or do they do the same thing? Same thing, okay? It will trigger anterior pituitary gland to release FSH and LH. Okay. Next, we have the FSH, the follicle stimulating hormone. Location of secretion, where does FSH come from? Well, we just wrote it down, right? It's going to be from the anterior pituitary. And what would be the trigger? Again, we just did it. The trigger would be increase in GnRH. Same for both sex, right? Male and female. And what does it do? Well, now we have to use different color. For a female, it will stimulate the development of follicle. Okay, this is essentially oogenesis. Right, you learned that last semester, right? The creation of an egg. As for male, FSH is going to stimulate spermatogenesis. Okay. Next, luteinizing hormone is also from the anterior pituitary gland. And that is also going to need an increase in GnRH. What does LH do in the female body? LH surge triggers ovulation. Okay. And creates corpus luteum, which in turn increases progesterone. Okay. And for male, it is going to increase testosterone output from interstitial cells. These are the cells that are found in between the seminiferous tubules, right? Okay, that's LH. Let's take a look at estrogen. This is female only. Location of secretion is, of course, the ovary, right? From the developing follicle. And the stimulus, the trigger for estrogen is going to be basically increase in FSH, right? So that causes the follicle to develop, which in turn pumps out estrogen from the ovary, right? And the effects, there are two effects. Increase GnRH, increase FSH, and increase LH through positive feedback, right? And we are going to have thickening, thickens endometrium. Okay, now in general, estrogen also is responsible for maintaining, well, not maintaining, but like how do I put it? It's is responsible for like during puberty, right? Estrogen is responsible for developing secondary sexual characteristics. Okay. Yeah, maybe we just stick with these ones. It's fine. Progesterone. Progesterone is also from the ovary, and it's from the corpus luteum. And the trigger is basically like increase in LH, right? During the second half. Okay, we can also say formation of corpus luteum. And progesterone will decrease GnRH, decrease FSH, decrease LH through negative feedback. And then it will further thicken endometrium. Okay. Testosterone. Testosterone. Where is it coming from? It's coming from the testis, right? the interstitial cells. And the trigger would be increase in LH, just like progesterone increase in LH, right, for female. And what it does is it will decrease GnRH, decrease FSH, decrease LH, again through negative feedback. As well, it would promote spermatogenesis. All right. And also, you know, it's important for developing secondary sexual characteristics during puberty. So like, you know, facial hair, deepening of the voice, right? That kind of stuff. Oh, that's it. We finished the chart faster than anticipated. And then, you know, the fill in the blank stuff you can work on your own. I actually lost the answer key to the study guide for lecture 11. I couldn't find it. So give me some time, okay? Like I'll type it up probably like tomorrow morning or something, and then I'll post it on eCentennial. But yeah, that's it. Okay. Next class we will do the last lecture. Probably gonna take us, you know, two classes, both Monday and Wednesday. And then on Wednesday we will take up lab 3. Right. And then you will do the lab 3 quiz on the following Monday. We'll do a test review on Monday as well, like the following Monday. And then that's it. You take the test and then you finish the program. Okay. All right. Thanks for coming. See you all next Monday. Bye for now.